right. All right, we want to welcome you to this special webinar 2012 with Mount Kilimanjaro. It's part of the Globe Seasons and Biomes project, and we have a bunch of people that are up on Mount Kilimanjaro that are going to be calling in here in about 5 minutes. Dr. Kenji Yoshikawa is going to be joining us in a little bit here. But we have a few things that we want to do before they join us by satellite phone and get you familiar with the Blackboard Collaborate and how this presentation is going to be happening. So the slides should be changing for you. Right now we have a slide showing the Blackboard Collaborate platform. The middle of your screen will be a picture that from a PowerPoint that that Kenji sent us and Elena have worked on, and we're going to share that with you today. And there's a chat area. You can type in your questions in the bottom left there. And Martha is standing by waiting for questions. She'll answer them as she can. You can also email her questions at mrcopeland@alaska.edu, and we'll put that back up again because some of you won't get to see it as the chat rolls through. So we'll remind you where to send questions if you didn't get a chance to have them answered before. There's also a list of participants. As you can see, there's a whole bunch of you there. Welcome everybody from around the world. If you have a question at the end, there we will have the opportunity, we hope, for you to ask them live. You will have to raise your hand. You click on the little hand icon above the list of participants, and that lets us know that, that you want to ask a question. This event is archived, and we'll send that out and post it on the website and give to the Globe folks to share in case you have to leave early. If you're joining by phone, this is some important instructions. We need you to mute your phone by pressing *6, and you also need to mute or turn down the sound on your computer so you don't get an echoing sound. Also, with more than one computer in the room, you also need to pick one computer to hear the sound from, or you'll get that echoing going on. A lot of people are joining us, and we would like to know where you're from and the number of students, so if you can post that on here. I know some of you did that earlier, but a lot of people just joined in the last 5 minutes, so if you don't mind reposting where you are from in the world, that gives us a good sense of who's joining us today. Again, if you have questions during the presentation, you can put them in the chat box, and at the end you can raise your hand and we'll call on you, and you'll need to press on the talk button if you're using voice over IP, and click on it once to open your mic, click on it once to close it. Again, there is no video today. So I have a slide up, and I think I'm actually going to have Elena respond to this slide before we hear from Kenji, where they are and what the heck they're doing.
In Kilimanjaro?
In Kilimanjaro.
Okay. So Dr. Kenji Yoshikawa is a hydrologist and permafrost scientist. So he's interested in looking at many different places in addition to Alaska and Russia and Greenland, the usual places where permafrost occurs. And he's interested in finding out whether in tropical mountains whether permafrost exists. And permafrost is the ground that has been frozen continuously for at least 2 years.
Okay.
And so there, with Dr. Yoshikawa are other scientists. One is another hydrologist from University of Alaska Fairbanks, a plant biologist from, two plant biologists from Japan, and one on specializing on tropical rainforests.
Okay, and I think we have Kenji and the folks joining us from Africa coming through here in a moment. Yep, hold on a moment.
right on.
Hello, this is Janet in Fairbanks.
Hi, I'm going to transfer Kenji.
Okay.
Okay.
Hello, this is Janet and Elena and Martha in Fairbanks, Alaska.
Oh, great. Hello, Jonathan, Elena, and Martha.
Hello, Kenji.
In Tanzania, and also John, the PolarTREC teacher, John, is next of me.
Okay.
Hello.
Yes, we hear you
Yep.
loud and clear, Kenji. So you are connected to the world right now. We have lots of people from all over that have joined us. They are able to hear you.
Great. Yeah, we are using satellite phone right now, and hopefully that is nice all the time.
Yes, it does break up a little bit when you talk, so talk slowly, clearly, and extra loud, Kenji.
Okay, I will try.
Very good. So where would you like us to start?
One of the biggest our weakness is I don't know what kind of slide you have and what kind of slide you present. I mean, every time when you show to the webinar, can you briefly explain about what kind of slide is in the display right now?
So we will go ahead and start on your first slide. So right now we have the globe program slide, but we'll skip that and just keep on going to the. Yes, right now we're showing you the title.
First show must be the globe. Explain about the globe season biome. Elena can explain.
Right. No, Kenji, we scrolled past the globe slides and the seasons and biomes. We're now on the first slide of your slides about tropical mountain permafrost. And so now we should move to the next slide. Okay, showing where mountains have permafrost, likely to have permafrost or unlikely. So you can talk about that.
Kenji, are you there, or did we lose you? We lost him.
Okay, let me go ahead and explain. There are, as you will see, slide 23.5 degrees north, the Tropic of Cancer, and 23.5 degrees south, the Tropic of Capricorn. There are mountains, the blue are mountains unlikely to have permafrost, and the red triangles designate the mountains that have been found to have permafrost. And the hand appeared on where Kilimanjaro is. Okay, next we should go ahead to the next one. And yeah, this just shows the distribution of incoming solar radiation at the top of the atmosphere, and focusing on the place between 23.5 degrees north and 23.5 degrees south. Okay, one of the main differences between the ground temperatures in, for example, Alaska, where permafrost is present, is the seasonal fluctuation. You can see, if you look at the left side of the chart, the depth of where the sensors are, from 0 to 6 meters and down to lower than that. And you can see the fluctuation of temperature of the soil, especially close to the surface of the soil, that it ranges from anywhere from colder than 15 below minus 15 degrees centigrade to 5 warmer than 5 degrees. And if you look on this is at 70 degrees north. And if you look at temperatures, ground temperatures in the equator, there is not much seasonal fluctuation.
All right. Sorry, Elena. I think we have Kenji. Yes. Hello.
Hello.
Hi.
Kenji again.
Hi, Kenji.
It looks like the questions are not so perfect, but hopefully we can do something.
So, Kenji, Elena was explaining your first couple slides about where we find permafrost in the mountains, and she is on the slide about seasonal fluctuation. We can go to the next slide, which specifically talks about the Kilimanjaro crater. So would you like to talk about what you're doing in permafrost at the Kilimanjaro crater?
Yeah, I can. Because what kind of slide do you have?
It shows the Kilimanjaro crater, the temperatures from October 1st, 2009 through September 2nd, 2010. And
I can also slide about Kilimanjaro summit.
Yes, on the crater at 5,785 meters.
Okay, maybe I think I got. Okay, I can talk now. Is it ready?
Yes.
Okay, so the Kilimanjaro, the summit of Kilimanjaro, air temperature is about -6 degrees C. Then same time we have a lot of heat from the ground. Then as everybody knows about the glacier covers most of the area. Then once a healthy glacier covers from the Kilimanjaro, they maintain the temperature stay almost 0 degrees C. And even the air temperature is -6 degrees C, but bottom of the glacier temperature is 0 degrees C, which is no permafrost. It's a healthy glacier like this. But as you know, recently glaciers retreating or thinning. And also the glacier surface exposed ice. That's easy to lose the heat. Then maintain the -60 degrees C or even very close to -60 degrees C temperature penetrate the ground, develop a new permafrost. So there are many areas in Kilimanjaro in the new developed permafrost today, the last 100 years. And this is one of the sites we can see today. Recently, the glacier site we drilled in 2009, try to keep out of temperature. And you can see that this graph almost stays 0, but still a negative temperature in the ground below 2 meters below surface. So that we are looking for. Then in this expression this year, we come to the more borehole near the glacier. And biggest exciting for us is if the glaciers disappear, temperature, how farmers' condition changing in soil. So I try to develop the borehole in the glacier, the temperature sensor and data logger measure every hour. Hopefully the glacier is gone. And how changing is before and after the glacier exist and gone, how temperature changing. That will make it to end at this expression. Okay?
Okay. Thank you for talking about the fluctuations. Maybe you can talk a little bit about, we have a slide that shows a map and it shows the mountain. Can you talk about other mountains? Other mountains. Can you talk about the differences and what you're finding?
Kenya and
we have a slide, Kenji, that says Kilimanjaro, Mount Kenya, and Ruwenzori.
Okay, I got. That means the entire Alaska map has a 3 mountains. That one?
Correct.
Okay. Okay, I can explain that. So Africa, the first thing is that we study about the quarterly permafrost glacier. Of course, we study talk about the polar region of Arctic or Antarctic. But if you see in the tropical region, if we go high enough, we have a glacier and permafrost. Then, if we look at Africa, we have a 3 mountain has a glacier, which is you see right now the picture. Place mountain Kilimanjaro, about it is 5,895 meters. Then second highest mountain is Mount Kenya, not far from Kilimanjaro. That was 5,199 meters. Then third highest mountain is Wendouree, not so far from Kilimanjaro. And Wendouree is about 5,099 meters. So that's the only 3 mountains has a higher than 5,000 meters in Africa, which is about repair.
Yes. Okay. Thank you. So the next is this the same? The next slide is showing 3 different pictures of the biome. And it has little triangles and has triangles. Yeah, nothing.
Showing the blue triangles and the red triangles where it indicates permafrost and no permafrost, likely. Probably the same that he was talking about.
Kenji, are you still there? We lost him.
Okay. So let's go to the next slide.
Okay.
Okay, this is showing the different elevations and the mean. I'm
sorry, Elena, I didn't mean to interrupt, but somebody joined by phone, and we can hear background noise. I hear a baby and some other things going on. So can you please mute your phone, *6 to mute your phone, *6 to unmute, and then that way we can make sure we have the best experience for everybody. Thank you very much. Okay, Elena.
Okay, so this graph shows the different elevations from 0 to 7,000 meters. And the mean annual ground temperature on the x-axis from -5 to 25, actually to 30 degrees Celsius. And the different triangles in actually the legend shows where Mauna Kea, that is a mountain in Hawaii, and where Kilimanjaro is, the square blue, in Mexico, and then in Peru, it's with an X, and it's very hard to see, but see, it shows what the mean annual ground temperature is. And Kilimanjaro shows that at almost 6,000 meters, the temperature is 0. This is the mean annual. So when you say mean, it actually averages the high and the low temperatures, the maximum and the minimum ground temperatures. And so this just shows the differences. And in Mauna Kea, you can see the temperature actually being, at the mean annual ground temperature being at the high 25 degrees C. Okay, maybe we should go to the next one. There. Okay, now this shows the ground temperature lapse rate, which actually is just showing the decrease in temperature as you increase in elevation. So you have the temperature in Celsius on the x-axis, and on the y, which is the one that goes vertically, shows the height of Kilimanjaro and what the ground temperature has been recorded. And Mount Kilimanjaro, just to remind everybody, is 3 degrees south. And this shows how the drilling and the insertion of the sensors for determining the ground temperatures. And it also shows the glacier in the background.
I want to ask Elena, how high is that glacier there?
My guess is probably at least 4,500 meters.
Wow. And how deep does the whole glacier run, and how extensive is it? Maybe we can see.
Well, yeah, we can see in this picture. And in this picture, they Kenji, Dr. Yoshikawa, has found that there are, because of the higher heat flow around the crater, because because it is a volcano, that there is no permafrost there. So it shows absence of permafrost because of the higher heat flow, greater than 20 degrees Celsius per meter. And so he indicated where he found permafrost on around the crater of Mount Kilimanjaro. And there's a MET station also indicating there. And you can see the glacier part on the...
oh, right there, where the station. What is a MET station again?
It's a meteorology station, so that it weathers. It's a weather station, and so it records air temperature, maximum, minimum, and amount of precipitation.
Are they going to be at that station and check that out on the trip, or do they go there?
I think so.
Oh,
yes.
cool. Okay, so we'll go on to the next slide, which looks like the crater.
Right.
That's what I call a crater.
Somebody wants to know what did you ask?
That's what I call a big crater.
Oh, yes.
You are right. Okay, let's hear from Elena what she's going to tell us about the crater.
Well, I was just going to say that indeed it is a huge crater, and that is formed when the volcano erupts and blows its top, and then the crater is formed. In some volcanoes, they actually form a lake in that crater, but not in this case.
Why is that? Is it just not enough precipitation, or why? Or does it keep having an outflow or something?
I'm not sure, but that is a likely possibility. I would have talked to a volcanologist on, crater formation and lake formation. It probably has a lot to do with the amount of precipitation.
Yeah. How deep is the crater?
How deep is the crater? I need to find out how deep the crater is.
I know. Now we're on to the crater stuff. This is exciting.
And this would have been good. Hopefully, Dr. Kenji will call back in.
Yeah. Okay. So the next slide here, the trail.
Right.
Nice.
So yeah, and so those are the glaciers that some of this. When was the last time the volcano erupted?
Not in recent times.
Yes.
So about the glaciers, how fast are the glaciers, are the glaciers on Mount Kilimanjaro receding like other places in the world, or are they the same, or what?
No, they have been receding since 1912. There actually has been a big loss of glacier mass. And to the glaciers in the Arctic, in the polar regions, the loss of glacier in Kilimanjaro is mainly due to the lack of precipitation. So that would, lack of snow, that would contribute to the glacier formation. And so it is not a direct consequence of higher temperature.
Okay. So it's not necessarily a climate change thing,
well,
or is it related?
It might be related because in places when they talk about climate change, it's not only temperature that is affected, but also precipitation. In some places, there's more precipitation, as indicated by the amount of flooding that's, the extreme events that's occurring, and some of those extreme events is flooding, which means excessive rainfall. Mm-hmm. But in the case of Kilimanjaro, it's the lack of.
Okay. Anything else you want about this slide, or should we?
No, I think we can go to the next slide.
Okay, so there was Martha's addressing your questions as they come in, but just to let you know, they've been communicating by satellite phone and cell phone from the mountain, depending on where they are. And hopefully we'll hear from Kenji in the satellite phone. It's a good reminder that communications are not the same worldwide, and we all get access all over the place. So that's how they're communicating. Okay, so we have a slide with springs on it. What's this about? Any idea?
There are several springs on the mountain. So from a hydrologist's point of view, it's very interesting to know how water moves from the mountain down to the area below, and that there are springs. It's not just glacial melt that contribute to the water coming off the runoff.
Okay. Oh yeah, so somebody wanted to know how deep is the crater, and another person here at Arcus looked it up. It's 350 meters deep.
Oh, excellent.
Yay.
Yay. Okay. So yeah, this is a good question that Mark and from George, they want to know what's the best time of year to do Kilimanjaro before we go on to this glacier slide.
I think the period where it is not during the rainy season.
And when's that?
There's a long rainy season in the spring, which would be like March into late April, May. And then there's a short rainy season that just finished in August to September. And so probably the period in the summer, what we call summer, between, say, May and September, and then starting now and into the winter months. Probably it's better then, because maybe it's a little bit easier for people to live in that area, because it's cooler for those of us who aren't tropical people, and so maybe it's a little bit easier to do research at that time.
Okay. Yeah, and the thing is actually ideal. The ideal is you can probably do research the whole year, and especially if you are using sensors connected to data loggers. But it's the access to the mountain that may be, the more difficult one to do.
So for the Mount Kilimanjaro expedition, Mike and the team, they only go up once a year.
Yes.
And it's mostly to have the students get a sense, learn about the different biomes and have this opportunity to work with the scientists.
Right. And the thing is, it is a very special opportunity, because usually to be able to see different biomes, you have to fly all over the world to see that. But here you have it in one mountain as you go up different elevations. Mm-hmm. And so with every 300-meter difference, then you can experience a different biome.
Hi, this is Jana and crew from Fairbanks, Alaska. This is Kenji.
Okay, this is John Wood. I'm going to hand the phone over to Kenji here. I just want to say hi, and here you go.
Great. Hi, John.
Hello, this is Kenji again.
Okay.
Hi, Kenji. Yes, we hear you, Kenji. So, so because you're, that's okay. Because you have short spurts of communication, can you just explain why, in general, you're in the mountain, what you're interested in, and why this is important science to you? Just give us a good sense of why, as a scientist, you need to be on Mount Kilimanjaro.
That's a real difficult question. So, Why? I think because one of the important is I think, okay, I can talk about many viewpoints we can discuss about this, but maybe only 2 points I can point out today. First is my profession, the permafrost. The permafrost issue, we want to see the permafrost distribution tropical regions, especially we don't know the permafrost. We have a lot of boreholes to temperature measurement in the polar region, almost nothing in tropical regions. So we want to establish the temperature monitoring site and measure the temperature. At the same time, most of the tropical glacier is retreating. As you know, the Andes or Africa or New Guinea. So then, once the glacier retreats, how ground property changing as ground thermal property changing on ground. That's using for permafrost. That's our first object for study here. But the second object is, of course, glacier and hydrology is very important topic in this area. For example, glacier is very important for the tourism in Tanzania, Kilimanjaro mountaineering. At the same time, the glacier is a big water reservoir for the adjacent villages for the agriculture. And possibly if the glacier retreats or disappear, definitely the hydrologic condition changing for the around the area. Then how impact the before and after the glacier changing, the hydrologically changing, how impact the villages that we want to evaluate. That's the second viewpoint. Does that make sense?
Yes, thank you. We have a question that maybe you can answer is how many glaciers are on Mount Kilimanjaro?
How many students?
Glaciers. How many glaciers are on Mount Kilimanjaro?
Glaciers. How many glaciers? One big one here, then a small one, maybe total, I don't know really how many, but one very big one, then maybe 10 small ones, something like this.
Okay. We had
big one.
Okay, we had another question that you can answer, and that is how many.
Oh, that's the water.
Well, where does the water flow and go
From the spring.
from the springs that come from Mount Kilimanjaro?
So that's the biggest question we don't know. That's why we really want to know about where the water, water resources go the pathway, like flash away or go to the percolate to the groundwater system. We don't know this contribution, the ratio, we don't know much about. First is we want to know about this. The second, if they go to the groundwater system, how much residence time, we don't know it either. I mean, different meaning. If the residence time is 2,000 years, the glacier, if the glacier is just 2,000 years, you have a things too. And we don't know the age of the springs, we don't know the pathway, that we try to understand. That's our first goal.
Okay, I have another question that they want to know, when was the last time the crater erupted?
Excuse me?
Hold on a second on the phone. I think, did we lose Kenji? Yeah. Yes, go ahead, ask your question. I see somebody's on the microphone.
How many people have climbed Kilimanjaro?
Oh.
Okay, I don't know. Elena and Martha are shaking their heads, so they don't know. So we'll write it down and we'll try to respond to your question either later today or through an email. But great question. Okay, there are some other ones that are coming up, and I know students want to ask some questions, so I think we'll try to go around the room and see what people have to say. I'll do one text one right here before I call on Elijah. The text one is, what types of wildlife do you find up by the glaciers? And I don't know if we can answer that or not, but...
Well, right up at the glaciers, you won't find many different types of wildlife at all. It gets very, very cold at nighttime. It can get down to -30, and there's not much vegetation up there. And so the types of wildlife that you see up there would be very tiny animals, maybe insects, maybe none at all. But as you go down the mountain, there are not howler monkeys, the colobus monkeys that live in the rainforest. They found tracks of elephants on the mountain, and that's again farther down the mountain. Many tropical birds in the rainforest. And then when you get down to the base of the mountain, you're in the Serengeti, and so you'll see zebras and giraffes and all of the big native African game animals that you can think of, antelopes and so forth. But at the summit itself, you really don't see any wildlife.
All right. So let's go to a live question. Elijah, so press the talk button once and to open up your mic, and then press it again. So go ahead.
I don't know how to do that.
Oh, you're on the phone. Did you do Elijah?
What?
Okay, I think we got your question answered. So we're going to go to another person. We're going to go to Henry Clark's school. Go ahead, Henry.
Here we go. Clark, I ask your question.
My question is, Lonnie Thompson, a glaciologist at Ohio State University, has concluded that the melting of recent years at Mount Kilimanjaro is unique. In 2000, he extracted deep cylinders of ice from Kilimanjaro's glaciers and found that the higher layers were full of elongated bubbles, signs that melting and refreezing had occurred in recent years. Is this a proof that climate change affects over the declining humidity levels in the glaciers beyond?
Yeah, I think the question is climate change affecting the humidity?
Did we get that right, Henry's class?
Yes.
Yes.
Okay. So we know that the humidity has decreased, and the amount of because the amount of precipitation has decreased. Now, whether we will attribute it directly to climate change, I'm not sure. It could be, but there are also evidence that the clearing of vegetation lower, down the mountain has maybe more of an effect than the immediate climate change.
Hi, Kenji. This is Janet.
Yeah, hi again.
Okay, so we have some more questions for you. We have some live questions that we responded to, but we want to know how many years of snowcap is left before total depletion on Mount Kilimanjaro?
How many years? Okay. We have a record. The first record is 1912. Everywhere we cover the ice cap, except several places. For example, the crater is very hot. So the regular places is still very hot. Then several open space in the middle of the ice cap. So other than that, most of the area, some areas covered by the glacier. Then also, we are kind of researching today with the students. We have 6 students with us and look at the hydrology protocol of the globe and student biome. And we look at the glacier retreating and look at the terminal moraines. We are saying about the 4,700 meters right now. And most of the valley has a terminal moraine. It's 4,700 or 4,800 meters, which is that moraine is a utilization moraine, which is only 100 years ago. I mean, about 100 or 200 years ago, I believe most of the elevation about 4,800 or like something 5,000 meter, more higher covered by the glacier. That we expected.
Okay. We had a question about animals and how many you've seen so far on this trip.
Actually, no, we don't see only monkey. It's different. Maybe John has a better idea. Because, PolarTREC teacher John, maybe he can answer to you.
Okay, that'd be great.
Hi, this is John.
Hi, John. We want to know how many animals you've seen on your trip so far.
Well, we did visit the Serengeti Plains and some areas around the mountain before we came up. And while we were on the plains, we saw a variety of animals.
Uh-oh. I think we lost you, John. We did. Darn. Come back. Okay. So as you can tell, they're having some communications and issues, and this slide that we have up shows where they were this morning. They were at 15,000 feet on the side of the mountain, so you can understand why they're having some issues. Again, we are trying to respond to questions through text, and we're keeping track of other questions. If you don't get to ask your question today, they will be responded to. Martha and Elena and all the Globe folks will try to do their best when we're offline. So we're going to go to Maria live and see what your class has to ask. So go ahead, Maria. Click on the top button to open up your mic.
Okay.
Is deforestation causing Mount Kilimanjaro's shrinking glacier?
Is deforestation affecting the shrinking glaciers?
Is that the question? Deforestation? Give us a thumbs up if we got the right question.
Yes, ask again.
Ask again.
Is deforestation causing Mount Kilimanjaro's shrinking glacier?
Some scientists say that that is one of the effects of deforestation.
Hold on, we're answering a question.
So, well, go ahead. And
Are you there?
okay. We can send you the article about deforestation and its effects on the mountain. Because when there are no vegetation, then there is less exchange of moisture between the vegetation and the soil, and you know that when in the hydrology cycle, it's all connected from precipitation, clouds, and then what falls on the ground. And when there's vegetation, then moisture can be released back into the atmosphere through transpiration of the plants. And so there might be a connection, and we have a paper that shows that there is a connection between that.
Okay, great. Thanks, Elena. We're going to go to Marcus. Would you guys like to ask your question? Press the talk button once to open your mic, and again to close it. Go ahead, Marcus.
I have a question. How hard is it for the youngest boy in your team, and is your team still complete?
How hard is it for the youngest? We will have to ask that question when we have somebody from the team, because you're asking about how hard is it for the youngest members of the team?
To climb the
mountain? Is that what we got? Is that the right question?
Yes.
Okay. Okay. I don't know. Elena may have those thoughts on this.
Well, I cannot answer for the team, but we know that people who climb the mountain, most of them actually do prepare themselves physically so that they can climb. One of the challenges in climbing the mountain is not just that you are physically able, but also that you are able to adjust to high altitude where there is not as much oxygen available as when you are on sea level or lower elevations.
Okay, thank you. Let's see.
We can ask that question when
we can
connected.
Yeah, we will. So how about Sue's class? Do you have a question?
We do. Can you hear us? Hello, can you hear us?
Yes.
Okay. So we have several, but we'll ask one because we know that everybody has questions. We were wondering, because it's warmer down in the crater, is the mountain in danger of erupting again?
Yeah. Well, the temperature of the warmer temperature does not have, I think, anything to do with the incidence of it erupting again. I think volcanologists would have a better, but I think right now, just because it's warmer, it is a fact that because we know that there's an active volcano there, that there are actually fumes and thermal regime, because it's active. That's why it's warmer. But I don't know whether that is a prediction of, or whether that is a prediction of when it might erupt next. But we will check with a volcanologist and ask their opinion about it.
Thank you.
Okay, great questions by all. Let's see, Barney, we can go to your classroom next.
Hello, can you hear me? Okay.
Yes.
My name is Elisa from Miss Peterson's classroom, and our question was, what were the team hauling up the mountain in the slide?
Oh, in the slide. Okay, they are hauling a generator up the mountain so that which will help them drill the holes so that they can put the temperature sensors deep in the ground, because the ground is very hard to drill into, and they need some extra help besides just muscles and elbow grease. So that is a generator.
Okay, nice question from Barney's class. Okay, I think we're going to end up getting Kenji and John Wood again, so hold on. Hello, it's Janet in Fairbanks. Welcome back.
Hello. Hello?
Yes.
Yes, we hear you.
Oh, hey, how you doing? We're back again. Sorry about the disconnection with the satellite.
That's okay, John. We're used to it. So I forgot where we left off, but we do have a question that came out, and maybe you can help us respond, John, and ask your team. There was one of the students wanted to know how the younger students, or how the students are doing in this whole climb. Are they acclimating well? Are they enjoying it? Are they getting to, they're working hard? How's it going for them?
Okay, that's a very good question, and the kids have been working pretty hard on the expedition. They've been having to do a variety of tasks, including, figuring out the protocols and helping with those, and conducting all the measurements on the streams and the different sites that we've been stopping at. Plus, they've been formulating their own scientific questions about the mountain and about the environments that we're seeing as we go up the mountain. Everybody's had their ups and downs as far as the altitude and everything, but we all seem to be holding up pretty good, and the kids are doing a great job.
Great, thank you. You were talking about animals and things that you were seeing around, but what have you guys been doing in the last couple of days? What did you do today? Are you just climbing, or are you doing science along the way?
Yes, basically we're working our way up the mountain from camp to camp. This is our 4th day on the mountain, and periodically Kenji has set up, his team has set up sites where there are samples being taken and have been taken in subsequent years. We've been stopping and taking those measurements, and then working our way up to the next camp and making notes and observations as we go.
Okay. I have a message from your school. They wanted to let you know that they are listening, and also Mary is also listening. So I just wanted to let you know you have some fans out there. There are some questions about what are you seeing in the rainforest, or what kinds of creatures did you see on the rainforest on your way up the mountain?
Oh, okay, yeah, thank you very much for that information. Hopefully I'll have a chance to say hi in a bit. But, in the rainforest biome that we passed through at the beginning of the expedition at the base of the mountain, there were just a variety of birds that were in the trees and everywhere. You could hear them just everywhere, even though we didn't get a chance to see a lot of them in the thick growth. And also we saw some colorless monkeys on several occasions. Oh, and some blue monkeys also.
Oh, cool.
Yeah, it was really fascinating to see all of the different varieties in such a small area.
Okay, good. So a question from Barney Peterson's class: what do animals eat in the various biomes? Not sure if you can answer that or not, John, but...
Okay, well, what do animals eat in the various biomes? Well, I would imagine, and I'll get some input here, the different animals have adapted themselves along with the plants in those biomes.
Oops.
So we're running across our, herbivores. And there's banana plants. There's
Okay, you're cutting out there, John. I don't know if we lost you altogether. Yep, we did. Okay, sorry about that. The satellite disconnected. We will probably try just for one more connection with the people on Kilimanjaro. It's getting pretty late there. They've had a long day climbing, and they have a big day ahead of them for tomorrow. Let's go back to the classrooms and answer some of your questions live. We have the STEM Magnet Lab. Would you like to ask your question? Press the talk button once to open your mic, and press it again to close it.
And the batteries get all
Did we have a question from STEM Magnet Lab? If not, we're going to move on to Judy. Okay, go ahead, Judy. Okay, go ahead. Okay, I guess at STEM Magnet Lab, you had your microphone on and I interrupted you. Go ahead, see if you can talk again. Okay, we are not hearing your microphone, so please just type your question in because we can't hear you at the moment. We're going to go to Mark's class, and go ahead and Mark, go ahead and ask your question. And then we're going to have to wrap up here pretty soon.
Hello, can you hear me?
Yes. Yes.
Oh, hi. Greetings from George, South Africa. And welcome everybody to the webinar. We have 2 previous expedition members here. And we have a question.
Good evening. I'm Grant Lodging here from Hibernia Primary School. I was privileged in 2009 to join the expedition up the mountain in Kilimanjaro, and the guides couldn't stress enough how these glaciers slowly over time will be disappearing. My question is, does these glaciers have a significant role on the ecosystem, and what impact will it have on the environment if these glaciers disappear?
Thank you. Great question. Elena is thinking this over, and I don't know.
Yeah, I would think so, that the glaciers would have an impact on the ecosystem, because I know that where the glaciers are not existing on top of on the summit, that is where the permafrost has formed. Because where there is glacier, it protects the glaciers protect the fluctuation in temperatures. Because as you know, when you went up the mountain, you've experienced really cold temperatures at night, but during the day, very hot temperatures because of the way the solar radiation is intense as you go up in elevation. And so with the loss of glaciers, there is more of a chance of the permafrost to form because of the very cold temperatures. However, the permafrost has a way of also being a barrier to the movement of water down into the soil. So it is a very complicated matter. It's not, a linear effect of you lose glaciers and one thing happens. There are many interrelated things. And of course, I think my idea is that glaciers will be a source of water as they melt. And if they're not there, then there wouldn't be that available.
Hello.
Hello. Thank you. Good question. Thank you, Elena. Hi again. So, John, just so you know, this will probably be our last. This will probably be our last connection with you, since many schools are wrapping it up and signing off. So, do we have some questions for you? You may have to put Kenji back on for this one, but how old is the ice on the top of Mount Kilimanjaro?
Okay, and could you repeat that question? How wet is the ice?
How old is the ice?
Oh, very good. Okay, hang on just a moment. How old is the ice on top? Uh-huh.
Yes, Kenji, we have a question. How old is the ice on top of Mount Kilimanjaro?
There is a great professor, Ronnie Thompson. He went through about 11 years ago. And there is a journal science published this question. I have it in my computer, but I don't have it in my head. I think something 1,200 years or something. I'm not quite remember, but not too old. Something like 12 or 1,600 years, if I remember correct.
Okay, great. And we'll save that question so that when you get back you can respond to it in writing. So we have another question, Kenji. Have you been taking rock samples on your way up the mountain, and what types of rocks have you found?
This is very much volcanoes. Volcanic, like a lot of lava flow, and most of the bedrock looking the lava flow. But except several ash layer, which is we focusing looking for, because the ash layer, the more air inside, the more good, lower the thermal conductivity can cool the frozen material stay frozen. So the mainly rock is lava. But several ash around there, and sometimes very frequent ash area there.
Okay, Kenji, we have another question that's appropriate for you. What happens when the permafrost melts?
So what happens to permafrost salt?
Yes, sauce.
At the Kilimanjaro.
Yes.
Yeah, I think it's sooner or later. Permafrost here is Septebmer, and they will stay there longer. Remember the earlier, like 200 years ago, most of the ice, Kilimanjaro has ice caps, glacier cover, which is no permafrost there. Then recently, recently glacier retreat, the thinner the glacier then developed the newly developed permafrost. Then once the glacier is completely gone, I think back again to the permafrost gone too. I mean, this permafrost is kind of short life, very different than the Arctic area.
Oh, okay. That's interesting. So we have another question. How long is the expedition going to take? Tell us what's happening next, Kenji.
Yeah, next, I mentioned about, for the cold region science exploration permafrost, the summit area is the most interesting. And we are going to summit area approaching very soon. The next 3 days, all of us is in the summit area. And we try to measure the heat flow from the environment. We measure the utility test how we measure the nighttime infrared picture to how heat surface looks like, and then many things we try to do at the summit area. That's what we try to do next.
Okay, great. Is there anything else we want to ask?
How old is the mountain?
Oh, we have a question. How old is Mount Kilimanjaro?
We know that.
Mount Kilimanjaro is a really complex structure. Very old mountains originally. Then a new eruption was made in Shibo, which is today's Kilimanjaro's highest point. And starting from volcanic activity, I think quite a bit old. And again, I'm sorry I don't get the number with me right now.
That's all right.
That's not here.
Okay. Well, so we wanted to thank you. There's been lots of schools, including the Valdez schools have been participating, Beaver, Alaska, the alumni from the Globe office in Africa there. So lots of people.
And this is, and we thank everybody for participating. Again, this is a Globe Seasons and Biomes, as well as a Globe Africa 2012 expedition. And so the Globe program engages students in doing environmental and earth system science investigations in different areas on atmosphere, soils, land cover, phenology, hydrology. And Seasons and Biomes is one of the earth system science projects, and Globe Africa is one of the 6 regions in the 112 countries involved in Globe.
Yeah, and it's been great to have the connection with Mount Kilimanjaro, and I think we lost them actually there, so that will probably be it for them. But again, we want to thank you for joining us, and if you haven't done so already, there is another event coming up on Monday, October 1st. This one will be focusing more on the education side of things and on the teachers, and we'll have the students. So that should be fun to hear what their experiences have been. And by that time, they should have summited.
Yes, it'll be the day that they come down. It will actually be from the base camp on the day that they've returned, and they will likely be extremely excited because it is a very, very energizing, exciting thing to come down from that altitude. So,
and with all the singing and dancing of the team the porters.
Oh, yeah.
It's just such an energizing, with them singing in Swahili.
That sounds fun. Well, we look forward to it. So anyway, thanks to all of you. Thanks to Martha and Elena for being here today with us, and Martha typing away frantically over there. If we didn't get to your questions, we apologize, but there is a way for you to email Martha, and maybe she'll put that back up here for you in the chat room. Email Martha your questions and she'll respond to you. And this event will be archived. We'll send it out to everybody that's registered, and we'll send the link to Martha and Elena so they can post it on the Globe site, as well as it will be accessible through the PolarTREC site. So again, thank you all, and we look forward to talking with you all next week.
And let's thank Arcus and PolarTREC in hosting this webinar.
You're welcome. All right, I'm